So again, welcome to the review of basic algebra. This is a college algebra course that I'm putting together. This is Unit 2 lectures. And this Unit 2 lectures, we are going to cover integer exponents and also scientific notations. So we're going to discuss the rules of exponents, also the rules for order of operation to evaluate expressions. We're also going to cover numbers in scientific notations and how to use scientific notation to simplify computations. So first, we're going to define the natural number exponent. Here we say that when two or more quantities are multiplied together, each quantity is called a factor of the product. So what we mean here is that, for example, if we have x raised to the power 4, it means s times x times x times x, which means we have 4 factors of x. Now, if x raised to the power 2, it means s will multiply itself twice. So we're going to have 2 factors of x. So that's what we mean here by when 2 or more quantities are multiplied together. Each quantity is called a factor of that product. So the exponential expression s raised to the power 4 indicates that x is to be used as a factor 4 times. So again, s raised to the power 4 will be x times x times x times x 4 times. So it's the 4 factors of x. So in exponential expression, example, s raised to the power n, this means s is called the base. X is the base. And then the n is the exponent. Or sometimes we may use the term power. That's more common. So for example, I can say s raised to the power n. X is the base and the n is the power or the exponent. So if we don't know the actual number, in this case, I will say n can represent any value. So here I'll say n factors of x. If it's 10, s raised to the power 10, it means s will multiply itself 10 times, which will be the 10 factors of x. So we have some examples here. Here the question says we should write each expression without using the exponent. So if I have 4 to the power 2, I don't want to use the exponent. The exponent is 2. So this is the same as writing 4 times 4 is 2. So 4 times 4, which will give us 16. So that's the solution here. 4 raised to the power 2 is the same as 4 times 4, which will give us 16. And this is read as 4 squared because it's 2 squared. The next example, we have negative 4 squared or raised to the power 2. Now we should be very mindful here. Since the negative is inside the parentheses, it means we're also going to square the negative. Now we know that negative times negative will give us positive. Positive times positive will give us positive. But negative times positive or positive times negative will give us negative. This is a rule that we have to know. So this means, again, negative 4 all square. Again, the negative is inside the parentheses, so the power affected it. So this is the same as writing negative 4 times negative 4. So negative times negative will give me positive. 4 times 4 again is 16. Now, the next example, we have negative 5 to the power 3 or exponent 3. Now, we can see that there's no parentheses. So this 5 only affected by the power. So which means the negative does not affected by the power. So the power does not affect the negative. So this is the same as writing, as we can see, negative 5 cubed will give me negative, so we'll write down the negative. Now, 5 cubed will be 5 times 5 times 5. So here you can see that we didn't write negative 5 times negative 5 times negative 5 because the cube or the power does not affect the negative value. The next example, we will see how the difference between negative affecting the power or not. So here you can see the negative 5 is in parentheses. So this time, the negative also have to be cubed. So it will be negative times negative times negative. Now, negative times negative will give me positive, times another negative will give me negative. So let's write down the first answer here. So we have the negative down, 5 times 5 times 5 is 125. Then let's go to example 4 or the D. Here we have negative 5, again, parentheses. So we can see that the negative also affected by the exponent or the power. So we have negative 5 times negative 5 times negative 5. So that will give me negative times negative is positive times another negative becomes negative. So we write down the negative, then 5 times 5 times 5 will give me 125. The next example, we have 3x to the power 4. Again, the exponent affected only the x, not the 3. So we write down the 3. X to the power 4 means x will multiply itself 4 times. So we have x times x times x times x. And that will give us the answer of 3x to the power 4. The next example, now we have 3x in parentheses to the power 4. So this means the 3 also affected by the exponent. So we get 3x times 3x times 3x times 3x. And this time we are going to get 81 times x times x times x times x. So we can see the difference. When everything is in the parentheses, the exponent affects everything. Again, here we have 3x to the power 4. So the x to the power 4 will be s times x times s times s. And 3 is by itself. But here, this time, the exponent affected it. So we have 3s times 3s times 3s times 3x. So this is, again, the basic concept of the power exponents or the power rules. So now we are going to apply the rules of the exponents now. Now, the first rule is called the product rule. The product rule for exponent. Here we are assuming we have m and n are natural numbers. If m and n are natural numbers, then x to the power m times x to the power n will be x to the power m plus n. What this means is that if the base is the same, so here we have x and x, the base is the same, and they are multiplying, then we add all the exponents. It can be more than 2 terms. For example, I can have x to the power m times x to the power n times x to the power w. Now, all the 3, they have the same base. So the power will be m plus n plus w. Now, if I have x to the power m times y to the power n, I cannot do anything because, again, the base are different. The rule said the base must be the same. So s to the power m times s to the power n will give me x n plus n. Also, we have the power rules of exponent. Now, if I have an exponent raised to another exponent, then I will multiply all the exponents. So here we have x to the power m to the power n again. So since we have 2 exponents, we multiply. So we get x m times n. Or another example here, we have xy to the power n. This means I'll get x to the power n times y to the power n because parentheses. And also here we have a division, x divided by y to the power n. Here we're going to multiply x to the power n divided by y to the power n because the power affected everything in the parentheses. We should be very mindful here. The base here are different, so we cannot combine. We're also going to go to the next rule, which is about, again, division. Here we did the product. Product, we said if the base are the same, we had the exponent. Here, if we have power raised to another power, we multiply all the powers. Now the next, if we have a exponent, actually let's do this first, 0 exponent. Zero exponent is a special rule. Anything raised to the power 0 is 1. So I can have x to the power 0 is 1, w to the power 0 is 1, million to the power 0 is 1. And also negative exponent means the reciprocal. We find the reciprocal of the expression. So for example, you have x to the power negative n is the same as writing 1 over x to the power n. Changing the negative sign to positive, we find the reciprocal of the value. So we have 1 over x to the power n. The same thing applies here. If I have 1 over x to the power negative n, in order to change the negative n to positive, I would say it's 1 over x to the power n. So that will give me xn, or x to the power n. Now let's go to the division and the quotient rule. The quotient rule said, when the bases are the same and we are dividing, we subtract the denominator exponent from the numerator exponent. So here we have x to the power m minus divided by x to the power n. We get x to the power m minus n. So again, the numerator exponent minus the denominator exponent. So let's do some example now. So far we have learned almost all the rules. We know the product rule, we know the quotient rule, we know the power rule, and the special rule for 0. Also, we know it. For a negative exponent, we know it. So now we are going to combine all these rules to do these 2 examples. Here they say we should simplify and write all answers without using negative exponent. So first thing I can do is I'm going to change the negative 2 to positive 2, which means I'm going to have a reciprocal of all the expression, which means I'll bring the denominator value up, then the numerator value down. So I'll turn it upside down to change this to positive. Then I know I have a negative here also. So this time y to the power negative 2 is down, so I'll bring it up. Then x to the power negative 2 was up, I'll bring it down. And that's one way of solving it. So first I'll change this to positive, then I'll change individual to positive. Or another way of solving it, I'm going to use the negative 2 to multiply everything in the expression. Then I'll again change the negative to positive. Either way, you get the answer. What I mean here is that first I can change the exponent negative 2 outside to positive by finding the reciprocal of all the expression. Then I'm going to find the individual negative exponent to positive exponent. Or I'll start with the individual negative to positive, then later I'll do the negative 2 to positive 2. So let's see how we solve it. So here we decided to write the expression again. X cubed, we combining the like terms together. Again, that's another way of going. So here we want to do the individual first before the outside exponent. That's also fine. So we have the same base, they are dividing. We know that the numerator exponent 3 minus 2. So we get 3 minus 2. Then we take the y. Negative 2, the numerator minus 3. So we have y raised to the power negative 2 minus 3. Everything raised to the power negative 2. So we combine the terms, negative with positive, so we get s to the power 5. Then negative will give me negative 5 to negative 2. Then I'm going to use the negative 2, multiply everything. I'll get x to the power negative 10, y positive 10 now, because negative 2 times negative 5 will give me 10. Then I'm going to change x to the power negative 10 to positive 10, so I find the reciprocal of it, which will give me 1 over x to the power positive 10 now. So finally, my answer will be y to the power 10 divided by x to the power 10. So this is another way of solving it. I think I prefer this method. Combine the like terms together first. We know this is division rule, so we subtract 3 and minus 2. Another division rule, y. So minus 2, minus 3. We find the exponent together, we get 5 and negative 5. We multiply, we use the power rule, multiply negative 2 by positive 5 and negative 5. We get negative 10 and positive 10. Now we use the reciprocal rule, negative exponent 1 over x to the power 10. Let's see the second example. So here we have x divided by y raised to the power negative m. So I'm going to use the negative m. Since here we have only two terms, x and y, they are divided. The base are not the same, so we can't even simplify it. So we just have, all we need to do here, multiply the negative n to the two terms. So here we get s raised to the power negative n, y raised to the power negative n also. Then again, these steps here, we go through all these steps, but normally what I would say is that find the reciprocal of this and reciprocal of the down. So basically we're going to turn it upside down. We get y to the power n divided by x to the power n, that's it. But here we want to again multiply the numerator and denominator by 1 in the form of x to the power n, y to the power n over x to the power n, y to, so we, again, when we cancel this, we get the same answer. But anything we do to the top of the expression, we do the same thing to the down of the expression. And the goal here is that we want to eliminate the negatives. So you can see that here we get x0 and y to the power n minus n will give me, again, 0. Because what will happen is that y, they are multiplied, so we get n plus minus n. So it will be n minus n, so that will give you 0. So you can see that we use this term so that we can cancel these two, 0, 0, and we get yn over xn. Or I'll just say straightforward, find the reciprocal of this. We turn the expression upside down, so we get y to the power n over x to the power n. Either way, we get the same answer. Okay, so next we go to the fraction to a negative power. Now we say that if n is a natural number, then x over y to the power negative n, turn it upside down. So it's the same as y over x to the power n. So the reason why previous example, we use this method, we are assuming that we don't know the rule that if we have negatives, we can turn the expression upside down to change it to positive. So now we know the rule, a negative power, turn the expression upside down. So we can solve this problem very straightforward, very quicker. So now we are going to apply the rules for order of operations to evaluate expressions, and some few examples here. First, we go through some strategy of evaluating expression using order of operations. Now we said that if an expression does not contain grouping symbols, such as parentheses or brackets, then follow these steps. Always we know that when we have any expression, the first item we have to simplify always is the parentheses or brackets. So here, find the value of any exponential expressions, perform all multiplications and all divisions working from left to right. So we know the order of operation, parentheses first, exponential, exponent, then what? Multiplication, division from left to right, then the last would be addition and subtraction. So we know the rule of arithmetic operations is the same thing applied to this expression, exponential expressions also. So let's see an example here. Here we have if x equal to -2 and y is 3 and z is equal to 24, they say we should evaluate the following two expressions. So all we need to do is that anywhere I see x, I'm going to substitute with -2. Anywhere I see y, I'm going to substitute with +3. Anywhere I see z, I'm going to substitute with 24. So let's solve the first expression. We have -x squared plus y squared z equal to, the expression have negative, so I'll bring down the negative first. We say x is -2, so I write -2, but it's x squared, so I have to write -2 squared, plus y. Y is 3, so I write down the 3, but it's y squared, so I write 3 squared. Then we go to the next, which is z. Again, there's slight error here, and bear with me. The z is supposed to be -4, so that's why we have -4 here. So again, assuming z is not 24, but rather -4. So we substitute. Now we know the order of operations. Well, in a parenthesis, I have only one simple value, so I'm just going to square this. -2 squared is 4. I write down the negative in the front down. -2 squared is 4, plus 3 squared is 9, -4. So the next thing, I'll multiply negative by +4, which will give me -4, plus I'll multiply 9 by -4, which will give me -36. So now I'm going to get -4. Positive times negative is negative. So we get -4, -36. So my final answer will be -40. So we are doing a very basic arithmetic operations, order of operations. First parenthesis, second exponent, then multiplication from left to right, addition, subtraction last. Again, assuming z is -4, not 24. So let's see the second expression. Remember we said z is -4, so you can see that the z cube, we substitute with -4 cube. We have 2 in the front, minus 3. We know y is 3, so 3 squared. The 5 is in the front. X is -2, so it will be -2 squared. Now we can simplify this expression. First, evaluate the exponent or the power. So -4 cubed will give me -64. 3 squared will give me +9. -2 squared will give me +4. Now we can do our multiplication. 2 times -64 will give me -128. Then -3 times 9 will give me -27. 5 times 4 will give me 20. I have negative value and another negative value, so I will combine the two values and keep the negative sign. So -28, -27 will give me -155 divided by 20. Again, 5 will go both 31 by 4, so we'll reduce it to -31 by 4. So that will be our final solution. Again, here we are doing the order of operation. Parentheses first, exponent, multiplication, and division together from left to right, and addition, subtraction. And from this question, the value of the variable x, y, z is given to us. Again, assuming z is -4. So if we have any expression with the variables, all we need to do is to substitute the values with the variables. So x is -2, x here will be -2 squared. Then we solve it. So next, how do we express numbers in scientific notation? So in scientific notation, we always have to transform the value. The end value should be a value that is at least 1, but not greater than 10. It should be less than 10. So it can be 9.999. So what we mean is that to be in a depth, 1 decimal place. 1 decimal place. So it can be 1.1, it can be in a 9.99, but the value of n should always be equal to or greater than 1 and less than 10. And that's what we said here. A number is written in scientific notation when it is written in the form n times 10 to the power n. The n value should be greater than or equal to 1 and should be less than 10. So let's see one example. Here they say we should write each number in the scientific notation. So I have 62,000. I'm going to count the decimal place. I know n should be 6.2 because it should be between 1 to less than 10. So I'll count the decimal places 1, 2, 3, 4. So I have 4 decimal places. So my answer will be 6.2 times 10 to the power 4. So here they say we must express 62,000 as a product of a number between 1 and 10 and some integer power of 10. This is accomplished by multiplying 6.2 by 10 to the power 4. I will count the number of decimal places that make it 6.2, and that's 4, so it will be 10 to the power 4. The next one, we have to be careful here. We are going to increase the value. So here we have negative 0.0027. So since I'm going to increase the value, I'll move the decimal place to my right side. My exponent will be a negative value. So here I'll move it to 1, 2, 3. So my answer will be negative 2.7 times 10 raised to the power negative 3, because I'm moving the parentheses to the right, increasing the value. The previous one, the exponent will be positive because I'm moving the decimal to my left. That is reducing the value. So that is the difference between the two. Now use the scientific notation now to simplify computation. And what we mean is that, for example, the question is given here and we want to simplify it. Instead of using a calculator, maybe multiply 3,400,000 by 0.00002 divided by, we are going to change it to scientific notation, and we may cancel some values. So first, I look at the first value is 3,400,000. So I'll count the decimal places 1, 2, 3, 4, 5, 6. So I'll get 3.4 times 10 to the power positive 6. I'm moving the parents, I'm going to the left, reducing the value. Now here I have 1, 2, 3, 4, 5. Remember, I'm going to the right, so I'm increasing the value. So it will be 2 times 10 raised to the power negative 5. We have 5 decimal places to reach 2. And here we have 170 million. So we count it 1, 2, 3, 4, 5, 6, 7, and 8. So we get 1.7 times 10 to the power 8. We are reducing the value, counting towards left. So this is what we get. 3.4 times 10 to the power 6, 2.0 times 10 to the power negative 5, because we move the decimal places to the right, divided by 1.7 times 10 to the power 8. We move to the left, reducing the value. So from here, we can cancel. Now we know that the base are the same, 10, 10 here. So we can use the power rules, 10, 10, 10. So here we get 10 to the power 6 plus, they are multiplying, 3.4 multiplied by 2.0. So it will be plus negative 5. The 10 to the power 8 is divided, so minus 8. So here we use the exponent rule. Now when we have 6 plus minus 5, this will give me again a minus value. So when we simplify this, we are going to get 1 minus 8, because 6 plus minus 5 will give me 6 minus 5, which will give me positive 1. Then 1 minus 8 will give me negative 7. So finally, our answer will be 4.0 times 10 to the power negative 7. This is in scientific notation. Now we can change it to decimal form. We have negative 7, so we have to get 7 decimal places. So I was here 1, 2, 3, 4, 5, 6, 7. Again, it's negative 7, so I have to reduce the value. I don't go to the right, reduce the value. So that will be our conclusion. So solving a problem using scientific notation means all the values we have to change it to our scientific notation, then we solve it. So we are going to end here. In these lectures, again, we went through the basic concept of a scientific notation as we saw it. And also we discussed about the exponent rules. We should know the product rule, quotient rule, and also special rules for the zeros, and also for the reciprocal negative exponent. So again, wish everybody the best, and thank you.